Uh, Objective number 1. Graph linear equations by plotting ordered pairs. Objective number 2. Find intercepts. Objective number 3. Graph linear equations of the form ax plus by equals 0. Objective number 4. Graph linear equations of the form y equal k or x equal to k. Note: to find the x-intercept, let y equal to 0 in the given equation and solve for x. Then, the x-intercept would be the ordered pair x, 0. To find the y-intercept, let x equal to 0 in the given equation, and then solve for y. Then, the y-intercept would be in the form 0, y. Example 1. Find the intercepts for the graph of each equation. Do not graph. Part A. The equation is 4x minus 3y equal 12. And we want to find both the x and the y-intercept. Let's find the x-intercept first. To find the x-intercept, I'm going to let y equal to 0 in this original equation. Therefore, we arrive at the equation 4x minus 3 times 0 equal 12. And thus, 4x equal to 12 and x equal to 3. Therefore, the x-intercept becomes the ordered pair of 3, 0. To get the y-intercept, remember, we let x equal to 0. So the equation becomes 4 times 0 minus 3y equal 12, and thus minus 3y equal to 12. Dividing both sides by minus 3, we get y equal minus 4. Therefore, the y-intercept becomes the ordered pair 0, minus 4. B. The equation is x plus 3y equals 0. Again, we're trying to find the x-intercept, so we're going to assign y a value of 0. Then the equation becomes x plus 3 times 0 equal to 0, and thus x equal to 0. So the x-intercept becomes the origin, which is 0, 0. And therefore, similarly for y-intercept, we assign x a value of 0, but also we discovered that y is going to equal to 0. So the y-intercept also becomes the ordered pair of 0, 0. C. The equation is minus 5x plus 2y equal 20. Once again, we're going to find the x-intercept first, though it doesn't matter which one we find first. But assigning the y value of 0 to get the x-intercept, the equation becomes minus 5x plus 2 times 0 equal 20, and thus minus 5x equal 20. Dividing both sides by minus 5, we get x equal minus 4. Therefore, the x-intercept becomes the ordered pair minus 4, 0. Similarly, to get the y-intercept, we assign x a value of 0 in the original equation. So we get minus 5 times 0 plus 2y equal 20. Thus, 2y equal to 20. Dividing both sides by 2, we get y equal 10. Therefore, the y-intercept becomes the ordered pair 0, 10. Example 2. Graph each linear equation. We're going to be looking at figure 5, 6, and 7 to reflect these graphs. But the first equation, equation A, is y equal x minus 4. In this equation, if we allow x to equal to 0, then y will equal minus 4. So one of our points for this graph, A, will be 0, minus 4. To get the y-coordinate, or rather the y-intercept for this graph, we let y equal to 0, and if y is equal to 0, solving for x, we get x equal to 4. So the second point for the graph for A becomes 4, 0. So if you look at figure 5, you see the 2 points that we just discerned, or the 2 points we just mentioned. Notice 0, minus 4, giving us the y-intercept, and 4, 0, giving us the x-intercept. So with those 2 points, we can draw the line graph that we see there that we call the graph for equation A. By a similar manner, we can get the graph for equation B, which is y equals minus x plus 5. Again, if you let x equal to 0, we get y equal to 5, which will give us a y-intercept of 0, 5. And to get the x-intercept, we assign y a value of 0, then subtract 5 from both sides. Dividing both sides in by minus 1, we get x equal to 5.